A spherical tank is full of water. Find the exact amount of work required to pump the water out of the spout, given that the radius of the spherical tank is 4 meters and the height of the spout is 3 meters as pictured below. Also notice I've set this up so that the x and y axes pass through the center of the spherical tank. Recall that work is equal to force times distance, and force equals mass times acceleration, which equals density times volume times acceleration. And now let's consider one thin disk of water in the tank, let's say here. Where the radius of the disk is r, the hydro thickness of the disk is delta y, the distance from the disk to the center of the tank is y, and the distance from the disk to the top of the tank here is 4 minus y. We can also label the distance from the center of the tank to the bottom of the tank as 4 minus y. For example, when y equals -2, let's say here, 4 minus -2 simplifies to 4 plus 2 or 6. This point is 6 meters from the top of the tank. And here's an enlargement of the disk of water. And now let's work on determining the volume of this thin disk of water in terms of y. To do this, we'll have to write the radius r in terms of y. Going back to the diagram, we can do this by forming a right triangle by sketching a segment from the center of the tank to the right edge of the disk of water here, which would be the radius of the spherical tank, which we know is 4 meters. So notice we have a right triangle here where the hypotenuse is 4, one leg is y, the other leg is r. Using the Pythagorean theorem, this indicates r squared plus y squared equals 4 squared. Solving for r squared, we have r squared equals 16 minus y squared. We can actually stop here because the volume formula calls for r squared, not r. But if we did want to solve for r, we would take the principal square root of both sides, which would give us r equals the square root of the quantity 16 minus y squared. So now we know we can express the volume of the disk of water as pi r squared h as pi times the quantity 16 minus y squared times delta y. So now we have the volume in terms of y. We also know the density of water is 1,000 kilograms per meters cubed, and the acceleration due to gravity is 9.8 meters per second squared. The last thing we need is the distance from the disk of water to the top of the spout. We know the distance from the disk of water to the top of the tank is 4 minus y, but then the spout is 3 meters, and therefore the disk must travel a total of 4 minus y plus 3, or 7 minus y meters. And now with this information, we can determine the increment of work it would take to pump this thin disk of water out the top of the spout. Again, that would be density times volume times acceleration times distance, and therefore delta W equals 1,000, the density of the water, times pi times the quantity 16 minus y squared times delta y, which is the volume of the disk of water, times 9.8, which is the acceleration due to gravity, times 7 minus y, which is the distance to the top of the spout. But we're looking for the total work to pump all of the water out of the spout, and therefore using the formula we just found for the increment of work, total work equals the limit as n approaches infinity of the sum from I equals 1 to n of 1,000 pi times the quantity 16 minus y sub I squared times 9.8 times the quantity 7 minus y sub I times delta y sub I. This is the exact formula above, except I moved the delta y to the right. And this limit should remind us of the definition of a definite integral. And because the water in the tank is from y equals -4 to y equals +4, the total work equals the definite integral from -4 to 4 of 1,000 pi times the quantity 16 minus y squared times 9.8 times 7 minus y dy. Notice we're only integrating from -4 to 4 where the water is. We're not integrating all the way to the top of the spout. Let's go ahead and simplify. 1,000 pi times 9.8 is 9,800 pi, and therefore the work equals 9,800 pi times integral from -4 to 4 of the product of 16 minus y squared and 7 minus y dy. Let's continue on the next slide. And now let's expand the integrand function, which I've shown here on the right by multiplying. We now have 9,800 pi times the integral from -4 to 4 of y cubed minus 7y squared minus 16y plus 112 dy. And now we determine the antiderivative, which is y to the fourth divided by 4, or 1/4 y to the fourth minus 7 times y cubed divided by 3, or minus 7/3 y cubed, minus 16 times y squared divided by 2, which simplifies to minus 8y squared, plus 112y. Next, we determine 9,800 pi times the difference of big F of 4 and big F of negative 4. Here's big F of 4, here's big F of negative 4. Simplifying, we have 9,800 pi times the difference of 320 and negative 832 divided by 3, which simplifies to 9,800 pi times 1,792 divided by 3, which is 17,561,600 divided by 3 pi joules. This is the total amount of work it takes to pump all of the water out of the spout. I hope you found this helpful.